Welcome to today's presentations on optimizing sole design in spike shoes for track and field athletes. So my name is Allecklyn with matric card number 74040. So in the world of athletes, even the smallest advantage can make significant difference. Today we'll explore how the right sole can enhance performance while reducing the risk of injuries. So the sole of spike shoes is crucial for power generation, traction and stability. It directly impacts an athlete's ability to excel. By understanding the biomechanics of sprinting and the roles of the footwear, we can unlock the secrets to developing the perfect spike shoe sole. Research has shown that the sole characteristics significantly affect performance and injury prevention. Stiffness, form and hardness can play a vital role. Balancing stability and cushioning can reduce impact forces and lower risk of injury from high-impact foot strikes. Creating the optimal spike shoe sole is an ongoing process of innovation and improvement. So, by combining scientific knowledge with industrial expertise, we can develop spike shoes that maximize speed, traction, and stability while minimizing the risk of injuries. So let's delve into the world of spike shoe sole design and discover how it can revolutionize track and field athletes. So our problem statement is the current spike shoe design in track and field lacks optimized sole configuration that simultaneously enhance performance and minimize injury risk, highlighting the needs for further investment in sole design based on biomechanical factors and research insights. And my matrix number is 74774. Today I will explain you about the pillar table. So for the fact is the weight of the spike shoe is light in which is resulting in reducing weight. So the idea is use lighter material in designing the spike shoe. For learning, what is the lightweight material that is suitable for spike shoes? And by the action is to reduce the overall weight of spike shoes. We will research on these two materials, polyurethane and carbon fiber, to compare which material are most suitable for our application, enable athletes to move with greater efficiency and speed.
So we have created a track sole specifically for 400 meters sprinting event. It is designed to give athletes the edge on the track. Here are some of the key features of our track sole. The first one is the measurement. The sole measures at 741.66mm in length overall, with specific dimensions at different points. For the toe section, it will be 245.51mm. For the center, it will be 176.56mm. For the heel, it will be 162.09mm. And at its thickest point, it measures at 37.17mm. So for the thickness of the sole, it falls within the range of 8 to 11mm, meeting the requirements for track events according to the World Athletic Guidelines 2022. And the material for our track sole is made of epoxy carbon UD 230 GPa pre-preg, which is a type of carbon fiber known for its strength and lightness. For the energy storage of our sole, the sole stores a significant amount of energy when it flexes upon initial ground contact, helping athletes to generate power with each step. Now, let's talk about the drawback of our design. First, it's the durability. Carbon fiber is less durable than rubber, so the sole may not last as long as rubber. For the traction, in some conditions, the sole may not provide as much traction as rubber. And lastly is the price. For a carbon fiber, it will cost more expensive compared to other materials. Overall, our track sole is designed to enhance athletes' performance on track. This is a simulation of our track sole, which was simulated with the specification mentioned in the previous slide. So on our simulation, there's only a blue color shown on the sole, which indicate that the track sole experiences minimal stress.
For the material analysis, we have two materials to analysis. Firstly is epoxy carbon UD. It has excellent strength to weight ratio. It is lightweight and has a high level of strength. Running spikes benefit from this since it allows for improved performance without adding needless weight. The epoxy carbon UD also has higher durability. The carbon fiber composites are renowned for their durability, especially epoxy carbon UD prepreg. They are well suited for the difficult conditions of running since they have high resilience to fatigue and can survive repeated stress and loading cycles. The second material we had analysis is the polyurethane. Polyurethane can be manufactured with low density, resulting in lightweight components without compromising strength and durability. This makes it advantageous for applications where weight reduction is important, such as automotive parts, aircraft components, and sports equipment. Besides that, polyurethane is known as for its exceptional durability and long lifespan. It is resistant to wear, tear, impact, and abrasion, making it suitable for applications that require high performance and longevity. Polyurethane exhibits excellent resilience and elasticity, meaning it can deform under pressure and return to its original shape when the pressure is released. This property makes it ideal for applications that involve shock absorption, cushioning, or vibration dampening. So for the analytical calculation result, we calculated the deflection at the end of sole for the carbon fiber and the polyurethane. For carbon fiber, it has deflection of negative 0.029 micrometer, and the polyurethane has deflection of negative 0.89 millimeter.
Hello, my name is Shafeeka, Binti Othman. For my part, which is cost analysis, has several factors need to be considered, such as material cost, manufacturing cost, labor cost, overhead and miscellaneous cost, and also the profit margin. For the material cost, for the sole, the cost will based on the quality, quantity, and supplier. Meanwhile, for the spikes, which is titanium alloy, the cost will be based on grade, quantity, and market condition, so that we get to know the pricing details. Next is manufacturing cost. For the sole manufacturing, the manufacturing process for the sole involves layout, curing, and finishing. So the cost will depend on the complexity of the design, required mold, labor cost, and machinery expenses. Same goes to the spike manufacturing. The cost will depend on the spike design complexity, labor cost, and machinery expenses. But add on, since it is spiked, the cost also depend on material wastage. And the labor cost. Labor cost can vary significantly based on the manufacturing location. We produce our spike shoes at Semenanjung. The different region has their own wage rates, so it may be higher shipping fee for come to Sarawak. So to ease our Sarawak athletes and affordable price, we chose Sarawak for the manufacturing location. For the overhead and miscellaneous costs, it includes costs associated with development, quality control, packaging, marketing, shipping, and other expenses related to bringing the product to market. Lastly is a profit margin, which is typically added to the total manufacturing. I want to compare our shoes with this one brand, which is Nike. The cost differences and the factors may be influence the pricing. First, the brand and reputation of the shoes. We know that Nike is a globally recognized brand known for its premium quality and innovative athletic footwear, where it often results in higher price points compared to other brands. While our shoes, which is new in this industry, tends to have a slightly more affordable pricing structure, which customer will choose the affordable pricing with the high quality also. And next is the technology and features. Nike, for example, Nike A Zoom Max Fly More Up-Tempo shoes is equipped with a Nike proprietary technologies such as A Zoom cushioning, which provides responsive and comfortable support. These advanced technologies and features can contribute a higher price tag. On the other hand, our shoes is a more streamlined track shoe designed for speed, focusing on lightweight performance rather than extensive cushioning technologies, which may lead to a comparatively lower cost. The material used in construction of the shoes also influence the cost. For our shoes, where we choose the material for the sole is epoxy carbon UD with 230 gigapascal, and for the spikes we chose titanium alloy, may be more expensive compared to other commonly used material in spike shoes. But Nike often incorporates premium materials and advanced manufacturing techniques, which can also contribute to higher production costs and consequently a higher retail price. So I think for the material and construction is a balanced cost for our shoes and the Nike one. The target market and intended use of the shoes can affect the pricing also. Like the Nike Air Zoom Max Fly More Up-Tempo is designed for athletes seeking high performance track shoes, potentially positioning it in a high-end market segment with corresponding pricing. Our shoes, still catering to performance-oriented athletes, may have a more accessible price range due to its focus on speed without extensive cushioning technologies. That's all.
In conclusion, we plan to running a shoes that are comfortable to wear, can reduce injury for each user, and can increase the speed of each user. After some discussion, we agreed to analyze the two material, which is polyethylene and carbon fiber, to make the sole of spike shoes. Then we did some research on these two materials to compare which material more suitable for our application, with using the engineering method to improve the sole of the spike in order to further improve the performance of the athlete in the general. And in the end of, we decided that the carbon fiber material was also the best because it made all the aspect we wanted. We choose carbon fiber because it have an excellent strength to weight ratio. It also has a higher durability.